Okay, parent functions 1.6. The goal today is to identify your parent function and know what's going on. That's the goal. Okay, the first one we are going to talk about, if my screen will switch, is linear. You always go, it's a line. Yes, everything is a line. It is a straight line. The parent function for linear is y equals x, right here. It's y equals x. So this equation right here has a y-intercept of what? Nope. Nope. 0. Because it is what? Y equals mx plus b. Yes? Been known those for a long time. So, as a y-intercept is 0, has a slope of what?
1 over 1.
1 over 1. So, graph your line. Yes? Is that what your line looks like?
Yes.
Okay. Technically, it has arrows on both ends, yes? But this doesn't give me arrows on both ends, only one. So there's some things we need to know about this. What is the domain of it?
Negative.
All real numbers. Or negative infinity to positive infinity. It's the same thing, right? X such that x is a set of all real numbers. What is the range?
All real numbers.
All real numbers. So y such that y is a set of all real numbers. Is it 1-to-1? Now we've talked a little about 1-to-1 last year. 1-to-1 means there's one x for every y and also one y for every x. So the test we have for that is the vertical and horizontal line test. So if I drew a vertical and a horizontal line, would it only hit once?
Yeah.
Yes. So is it 1-to-1?
Yes.
Yes. We will talk more about 1-to-1. End behavior. End behavior is what is it doing over here and what is it doing over here. So we talk about as x approaches this way. So you say as x approaches negative infinity, let me put this in a parenthesis, comma, y approaches what? What are my y? As my x's go this way, what are my y's doing?
Infinity going down.
So what kind of infinity?
Positive.
Negative infinity. Goes down, Riley. So that would be negative. So now as x approaches positive infinity, comma, y approaches what?
Infinity. Positive.
Positive infinity also. When I ask you guys for end behavior, you just do this. But the book will write it like this, so we need to know how to read it, okay? This means as x approaches negative, what's y doing? Approaching negative. As x approaches positive, y is approaching negative, okay? Intercepts. What are the x and y intercepts?
0, 0.
Okay, so the x-intercept is 0, 0. And the y-intercept is also 0, 0. And we discussed this yesterday. If the x-intercept is 0, 0, the y-intercept has to be, correct? Extrema, that's min or max. Okay? So if you want to write min, max, so you know. Does it have one? It goes to negative infinity and it goes to positive infinity. Does it ever get to those? Okay, so it has none. Okay, is this graph, or where is this graph increasing or decreasing? Does it have any extrema? Because I said increasing and decreasing happens at extrema, yes? Does it have any?
No.
Nope, so it's doing one thing the whole time. Is it increasing or decreasing from left to right?
Increasing.
Increasing. So it isn't decreasing ever. So from negative infinity to positive infinity, it is increasing. Okay, continuity. Is it continuous?
Yes.
Yes. There's no holes. There's no breaks. There's no sharp turns. So it's yes. Now, we talk about the anchor point on these graphs. The point that we are going to use our H and our K on. On here, it is 0, 0. But do we do H and K with linear functions? No, we do y-intercept and count the slope. I will not be making you guys do H and K with linear functions. That doesn't make any sense to do. Questions on linear? Okay, next is quadratic. So let's draw it. Well, let's see. Quadratic. Can you see the yellow when I do the yellow? I kind of liked it. If I plug in 0, I get out what? 0. Can you see that? How about I make my dot bigger? Okay, so we probably should just plug in another point, right? So give me another x. 2. If I plug in 2, what do I get?
4.
So I go over 2, up 4.
Yeah.
Now, could I put 6? Yeah, but do I have it on the graph? No. Okay. What about if I went right 2, I probably should go left 2? So if I plug in negative 2, I still get what?
Negative 4.
No. Negative 2 times negative 2 is
4.
4. So I get something like this. And we know that this is a parabola, correct? So it doesn't let me draw parabolas. So we'll see how good my artistic skills are. So a parabola looks like this, yes? So my vertex is down here. And it goes up. And you better not go through 3 because we don't have 9 on this graph, do we? And it goes up. Is it symmetric?
Yeah.
Yeah, it's the same on either side of it, right? So this is the parent function. My vertex, my anchor point is right here. The way I write it out is y equals, remember the plus or minus a, x minus h squared plus k. Correct? Okay, so when I'm moving this right here is my h and my k. The initial h and k is 0, 0, isn't it? Yes. Okay, so just remember that, and it will get easier as we work on it. Let me take that out. So domain, all real numbers. Range. Look at your picture.
From the 0.
From the 0, what?
Up.
Up. So y is greater than equal to 0?
Yes.
Okay, we can visually see a graph is an output of all the y's. That's what we're actually connecting, So 1 to 1. If I draw a vertical line test, does it pass?
Yeah.
It's a function, right? What about a horizontal line test? Does it pass? No, because it would hit twice everywhere but the vertex, wouldn't it? So it is not 1-to-1. Or no, whatever. Okay, end behavior. As x approaches negative infinity, y approaches, now again, x approaches negative infinity this way. What is y approaching? What are my y's doing?
Positive infinity.
Going to positive infinity. And as x approaches positive infinity, what are my y's approaching?
Negative infinity.
Positive. So as x goes out here, my y's are going up. Now, that is a difference. This is an even function. We've talked about even functions, right? And they start and stop in the same place. So if I ask you to tell me what the end behavior was of some quadratic equation, you would either tell me up, up, or down, down if x was negative, wouldn't you? So you can write it like this, but it's really lengthy.
Wait, explain this to me. How are you doing this?
How am I doing what?
The end behavior.
Okay, as x goes out to negative infinity, what are my y's doing?
Oh, in my. Okay.
As x goes to positive infinity, what are my y's doing? Okay. Intercepts. X-intercept.
0, 0.
Y-intercept.
0, 0.
And if it's a function, there's only going to be one y-intercept, isn't it? Okay, extrema. Does it have a max or a min?
The min, yeah.
Yes, where does it have a min at?
0, 0.
0, 0. So usually when we do minimum, we just say where x equals 0. Because if I know the x, can I always find the y?
Yes.
Yes. When we talk about things like intervals, we state the x's because the y's come along with them. Okay, increasing and decreasing happen at an extrema. And since we have an extrema, we're going to have this happening, correct?
Yep.
Okay, so from the left, from negative infinity, what's the y's doing if I'm coming this way? They're going what? Down. So it's decreasing from negative infinity to 0. And then it, as I keep going, it's going to go where? Up. So from 0 to, my brackets aren't very curly today. Is it continuous? Yep. So continuity, does it have any holes, breaks, or sharp turns? The answer is no, and so the answer is
Yes.
yes. Am I good? Okay, cubic. So I told you H and K, right? So it would be y equals a plus or minus a, right? X minus h cubed plus k. Same thing's going to happen. I can move it left, right, up, down, backwards. Okay. So if I plug in 0, what do I get? 0. Give me another number. I got to cube it and keep it on here.
2,
2?
1.
Well, if I go 2 and I go by 2s, we'll do that. 2 and I go by 2s.
Yeah.
So 2 cubed is 8.
Yeah.
So 2, 2, 4, 2, 4, 6, 8. Okay? And then if I'm going to go positive 2, I should probably go, what, negative 2?
Yeah.
So negative 2 would give me a negative 8 because I'm cubing it. So 2, 2, 4, 6, 8. Could I do 1?
Yeah.
So it'd be like right in the middle. Right there. And right there, my dots are really big. So this graph goes like that, doesn't it? I mean, that's the way my dots took me, didn't it?
Yep.
Yep. So there's my graph. This would be considered an odd function because it starts and stops in two different directions. Looks funny. Okay, what is my domain?
All real numbers.
All real numbers. What is my range?
All real numbers.
All real numbers. Since it goes in both directions, am I hitting all of those?
Yes.
Yes. Okay, is it 1 to 1?
Yes.
It is. End behavior. As x approaches negative infinity, comma, y approaches what? Negative infinity. And as x approaches positive infinity, y approaches positive infinity. And if you were answering end behavior for me, I would do that. Intercepts.
0,
0, 0 for the x. And 0, 0 for the y. Okay, my vertex, my anchor point is what? 0, 0. That's that H and that K. Extrema. No, it doesn't. This thing increases from here to here. So there's no extrema. And it's increasing from negative infinity to positive infinity. Now, if I threw a negative in front of that, then it would be decreasing, wouldn't it? Because it would end down. Decreasing, not happening. Is it continuous?
Yes, sir.
No holes, no sharp turns, no breaks. Easier than you guys thought, wasn't it? And if all else fails, if you don't know how to graph something, pick points and plot them, right? All good? Okay, key absolute value. Okay, so absolute value, again, I could write it as y equals plus or minus a, the absolute value of x minus h plus k. You didn't believe me that those h's and k's would be in every single thing, but they are. They were last year when I told you, weren't they? Okay, so what point do you want to plug in here?
0, 0.
0, and you get 0. Next,
3.
3. If I plug in 3, I get what? 3. So if you plugged in 3, you probably should plug in
Negative 3.
-3, and you get what?
Negative 3.
No, you do not.
3.
You get 3. So if I plugged in 4, I would get what?
4.
Actually, let's plug in 5. If I plug in 5, I get 5. If I plug in -5, I would get...
5.
So what's this thing look like?
Doesn't it look like a V?
It does look like a V. So it's going to go... like that. So what is its domain? All real numbers. Okay, I'm good. What's its range?
0.
Y is greater than or equal to 0.
Y is greater than equal to 0. Because if everything comes out positive, the parent function isn't going to go negative, is it? Now, if I move it down, if I change my k, can I get some negatives out of there? Yep. But if I change my k, that's going to change my range, isn't it? Okay, is it 1 to 1?
No.
No. Which one does it fail? A horizontal line test. Okay, end behavior. As x approaches negative infinity, y approaches what?
Negative infinity.
Look at your picture. Positive. Because as I'm going out to negative infinity, my y's are going up. As x approaches positive infinity, y approaches positive infinity. So if you were drawing your arrows for me, you would do what? Up, up. X-intercept,
0, 0.
y-intercept,
0, 0.
extrema.
The min.
There's a min, right? Min at where?
0, 0.
0, 0, or x equals 0. Okay? So that means it has to be increasing or decreasing. It has to be one of each at least, right? Okay, so when I'm coming from the left,
Decreasing.
it's decreasing. So negative infinity to what?
0.
0, it's decreasing.
And increasing 0.
And then increasing 0 to
Positive.
positive infinity. Now, my question for continuity, does it have any holes?
No.
Breaks?
No.
The last one is sharp turns.
That I guess. Yeah.
It has a right angle turn. Well, this one does, yes? Like, is this a nice gradual shape?
No.
No. I go, so is this continuous?
No.
No. It has a discontinuity. It is not. It is discontinuous at where? X equals what?
1. I mean 0.
0. Okay, it is discontinuous at x equals 0 because of what, guys?
Sharp.
That sharp turn. And as I would adjust it, like if I had one that looked like this, would it be very clear that that's a sharp turn?
Yes.
Yes. We're doing discontinuities today in calculus. Look at me prep you for calc. Are we good?
Yeah. Yep.
Okay, square root. So square root is y equals, can anybody tell me?
What's your minus a? That's all I got for you.
And what function are we?
Root of
Square-
X minus H plus K.
X minus h. Make sure you close that square root so you know that the k is not in it, right?
Good morning, Mr. Murphy.
Good morning, Jody.
Okay, let's graph it, guys. What point do you want to use?
0.
So the rumor is your first
Okay, so
0.
0. If I plug in 0, I get what? 0. I'm going to plug in negative 6.
No.
Why not?
Hey, want to make a selection?
There can't be a negative and a zero.
I cannot take a negative of an even root, can I? No, because that would be an imaginary number. That would be an I.
Let's do
So let's do 4.
9.
Well, you don't have 9 on here.
Well, we could get 9 on there.
So the square root of 4 is what?
2.
2. I can't fit 9 on mine. If you want to fit 9, then you go for it. So what's this thing do? Does it go straight through that? How about, let's go. What about 1? What's the square root of 1? 1. So this isn't straight, obviously, is it? Because if I did straight, it would look like this, and I wouldn't get 1, would I? Okay, so it has to curve. I always say it kind of looks like a square root.
I'll do this.
Looks like half of a parabola, yes? Because technically it is. When you square root a square, you get what's inside, right? Okay, so domain?
Oh, really?
No.
I don't know.
We just had this discussion.
How
X is greater than or equal to 0.
X is greater than or equal to 0 because you cannot put a negative in a even root, correct?
Yep.
You can take the negative of a cube root or a 7th root or a 19th root, but you cannot take the 6th, the 2nd, the 28th of a negative number.
Or the 4th.
Or the 4th. Range. Y is greater than or equal to 0. Is it 1 to 1?
Yeah.
Yes. Now, end behavior, I don't even have to talk about over here, do I? Because it's not my domain, is it?
Nope.
So as x approaches positive infinity, y approaches what? Positive infinity. Slowly, but it does, doesn't it?
Yeah.
Okay. Intercepts. So the x and y is at 0, 0.
So on end behavior, would we just give you an up arrow?
Oh, yes, you would. Well, yeah, yeah. I don't tend to ask you on a square root, but yeah. Or you could show me how big your brain is and do it the right way on that one. Okay, any extrema? Yeah, has a minimum, doesn't it? Where's its minimum?
0.
X equals 0. So this one, normally you'd be increasing, like it would have an increasing, decreasing, but square root's a little funny, isn't it? Does it have a decreasing ever? Nope, it only has a what? So this one doesn't start at negative infinity, it starts at 0 to positive infinity. Okay, continuity. Yes. Okay, that's it? Okay, so your homework today is just using these kind of skills, talking about different stuff. It's kind of random.